Hi, my name is Mohammad Rizwan and I would like to welcome you to this short tutorial on Decorator Design Pattern. I will be going to demonstrate what design patterns are and the significance of considering them while designing our applications. I will discuss in detail one of the most commonly used decorator design pattern, the problem it addresses and the solution it offers to elegantly deal with it. I will then move on and discuss the guidelines that we have to follow to correctly implement this pattern in our application. So without any further ado, let's get started. So as soon as we hit the ground running with the object-oriented development, we will normally get confronted with a couple of design problems along the way. The object-oriented paradigm does not provide any guidelines on how to be effective in such cases. This is where design patterns comes into play. Think of design patterns as proven tested solutions for common design problems that we all came across at some point during our development. Consider them as suggestions that should be taken into account when designing applications to avoid any consequences that might appear sometimes later during the development process. For example, when designing application, if we came across a situation where the requirement is to add more dynamic behavior to the objects of the class without extending the class itself with these additional responsibilities, simply because it doesn't make any significance in the context of the class itself and is only meant to add more details to what was actually made available to us by the class. This is where the decorator design pattern kicks in. This pattern provides us with a mechanism on how we could attach additional functionalities to the objects of the class during the program execution. Of course, if you have some better alternatives, feel free to choose them. Considering the fact that these solutions are battle hardened tested, it is sensible to go with them instead of having to come up with our own suggestions, which could lead to unwanted results. Here I have taken the anatomy of the colored assorted bulbs installed in our premises to demonstrate the fact that these bulbs gives us the illusion of different colors of light emitted by the diodes, even though the actual light produced by the bulbs is of warm white or yellowish in color. So these colored glasses takes on the light produced by the bulb and further decorate it with the color of the glass without fiddling with the actual characteristics of the bulb itself. Down below, we try to simulate the same behavior using classes and objects. So here I have instantiated a couple of objects that corresponds to the bulb class. These objects contain two methods. One encapsulates the logic to switch the bulb on and the other one to switch it off. The turn on method simulates the generic behavior of emitting the yellowish colored light out of it. Now what if we want to add an additional feature to the individual bulb objects in terms of emitting lights of different colors for its consumers? This is where the decorator design pattern outshines. This pattern dictates that to add additional responsibility to the class, we need to introduce another class that models the same behavior as the class that requires extensibility. Here, since we want the bulb class to give the illusion of a colored light, we have to come up with another class that have both turn on and turn off methods defined as part of it. You may have argued at this point that we do not see any significance of defining the turn off method in the new class because it doesn't extend the meaning of the actual turn off method by any means. But the matter of the fact is that once we have a new class in place, we are not directly interfacing with the bulb class anymore and rather consulting the new class for the intended behavior. The new class should have all the methods defined with the same name and signature to pretend the behavior of the actual class to the other parts of the program. These methods provides us a way to decorate the calls to the actual methods by extending it with the desired behavior. So in this case, the objects of the color assorted bulb class refers to the turn on method of the bulb class in its turn on method to do the real work of emitting the light out of it, and further goes on and decorate the call with the colored glass to simulate the desired behavior. The decorator design pattern guideline dictates that to extend the class with additional behavior, it should adhere to the rules set for this pattern. First, we need to introduce a class that have the same interface or methods originally offered by the bulb class. Here we have added both turn on and turn off methods to the red assorted bulb class to pretend the behavior of the actual bulb class. As the name reflects, this class is intended to give the illusion of red light coming out of the bulb. The next step is for the consumer to create an instance of this red assorted bulb class and further provide it with the bulb instance that this class is meant to extend in terms of adding more behavior to what was actually offered by the bulb class itself. Next, the consumer makes a call to the turn on method on the decorated class in order to switch on the bulb. The decorated class then goes on and call the same method on the bulb class to do the actual work of producing light out of it. Once the bulb class method finishes executing, the control jumps back to its caller class. Given this class an opportunity to decorate the produced light with red color to simulate the effect of red light coming out of the bulb for its consumers. Let's now switch to the Eclipse IDE to see the decorator design pattern in action. Here I have created a decorator class that requires an instance of the class it is supposed to decorate during object creation. When the consumer makes a call to its turn on method, it goes on and call the turn on method on the bulb instance and further adds some additional behavior on top of it before returning it back to its consumer. Since nothing needs to be added to the turn off method, so we are simply returning from the method without extending it by any means. Bulb class methods encapsulates the actual functionality of the bulb. Turn on to start producing light and turn off to stop emitting it. Here, inside the main method that acts as an entry point for the console-based applications, we have created an instance of the red assorted bulb class and further provided with the actual bulb instance. Once an instance is created, we are calling the methods on the instance for the desired results. As an exercise, I would like you to pause the video now and create a console-based application and manually type the code shown here for each one of these classes. Then run the program and examine the output for details. This finally wraps our discussion on the decorator design pattern. I hope that this tutorial will help to better understand the intricacies of the design patterns in general and the decorator design pattern in particular. Before I say goodbye to you, I would like to request you to please subscribe to this channel for latest updates. Goodbye and see you in the upcoming courses.